Here we have a differential equation to solve, and I gave you a hint to use the integrating factor method. The differential equation is x squared dy by dx plus x cubed y is equal to x squared e to the half x minus x squared. I'm going to ask you to pause the video and solve it. Okay, so you're finished? Alright, so let's work it out. Let's see something here. The hint is to use the integrating factor. Now, as long as you can write it, or you have it in the form dy by dx plus py equal q, then you can use the integrating factor to solve it. Let's see something here. Oh, suppose we divide by x squared. Then what we have is dy by dx plus x cubed over x squared is x. We have xy equals, well, this x squared would cancel. So we have e to the half x minus x squared. Okay, good. Now, you can see that p is x, right? Now, the integrating factor is equal to e to the integral of p dx in general. In this case, it is e to the integral of x dx. What's the integral of x? We have e to the integral of x is x squared over 2. The x squared over 2. Right? We leave out the constant of integration sign here. So using the power rule, it's x squared divided by 2. Let's write this as e to the half x squared. Time it's a bit easier on the brain, right? When you have a number x squared instead of having x squared over a number. Alright, so the next step is to multiply by the integrating factor. Alright? So we multiply both sides by the integrating factor. So we have e to the half x squared multiplied by dy by dx plus e to the half x squared multiplied by xy is equal to e to the half x squared multiplied by e to the half x minus x squared. Alright, so that's what we have. On the left hand side, this is you expect it to be the result you will get from differentiating a product using the product rule. So you must identify the product. All right, identify the product. What is that product? Because you differentiated that product, so you found the derivative with respect to x of some product to get this. What's the product? Obviously. And by the way, before we do that, remember the product rule. You have two functions. Say you have u and the function v. You're finding d by dx of uv. So you hold u as it is, don't do anything to it, time, differentiate v with respect to x, dv with respect to x, plus you hold v as it is, don't make any changes to it, times the derivative with respect to x of u. So it's the derivative of uv is equal to you whole u differentiate v plus you whole v differentiate u. Alright? So that's the product rule, just a reminder. So, let's not erase that yet. Let's look at this. What did you differentiate here? You differentiated y with respect to x. And you hold y here. So one member of that product is y. Y multiplies something. What was it? If you differentiate y here, that means you would have held e to the half x squared. So the other member of that product must be e to the half x squared. Alright? What it means is that if you separate the y from everything else, what you will be left with is what you get from differentiating e to the half x squared. When you differentiate e to the half x squared, when you differentiate e to the half x squared, you're supposed to get x. You're supposed to get e to the half x squared times x. How does that really work? Let's go one side and actually work it out and see what happened. Alright? We don't want to just skip over it if you don't understand exactly where that came from. Let's work it out. One side. Let y be equal to e to the half x squared. When we're done, it's supposed to have x times e to the half x squared. So let's see something. We're going to use the chain rule. And by the way, remember the chain rule, dy by dx is equal to dy by du, that's one link in the chain, times the second link in the chain, du by dx. And notice it's like the du cancel du here, leaving dy over dx, which is dy by dx, right? So we need to find out some type of substitution u. Let u be equal to half x squared. So du by dx equal what? Using the power rule, it's going to be half times 2x to the 2 minus 1. But 2 minus 1 is 1, so it's x. Half times 2 is 1. So du by dx is x. See that? And then, if we let u be equal to half x squared, then what we have is y is e to the u. So dy by du is e to the u. Remember, when you have y equal e to the x, differentiate, dy by dx is e to the x. The same e to the x. Alright? So here, dy by du is e to the same u, e to the u. But what was u again? U was half x squared, so it's e to the half x squared. Now, dy by dx is dy by du, which is e to the half x squared times du by dx. Du by dx is x. So it's e to the half x squared times x. E to the half x squared times x. So that's exactly what we have right here. E to the half x squared times x, and then the y. Alright? So it's e to the half x squared times x. So you see that? Make sure you understand where that comes from. We're going to work out what is on the right hand side. We simplify what is over here. We have e to a power times e to another power. We're going to add the powers. Remember, you're roots of indices. So it's e to the, we have half x squared plus half x minus x squared. We open the bracket, we have e to the half x squared plus half times x minus multiply the half x squared. So what happens here is e to the, oh guess what? The half x squared minus half x squared, that is gone. So what we have is e to the half x, e to the half x. So that's what we have there. All right. Now, so we have on the left d by dx of y e to the half x squared is equal to this. Now, to get rid of the d by dx, what do you do? The d by dx indicates a derivative. What do you do to reverse a derivative? The inverse of differentiation is integration. So the next step is to integrate. So the integral of d by dx of y e to the half x squared is equal to the integral of e to the half x. All right. Now, let's work this out first. What's the integral of e to the half x? The integral of e to the half x. We want to work that out. Now, dx. Oh, I have dx. I need to show what is the variable. Some things are variables, some things are constant here. What's the variable here? It's x, so I have dx. dx, all right? So it's e to the half x dx. Let's use integration by substitution and see what we get. If we have u being half x, when we integrate, we have e to the integral of e to the u dx, but we want e to the u du. So what happened here? Du by dx is going to be, when we differentiate half x, what do we get? Well, half times 1 x to the 0 using the power rule. This is x to the 1. 1, the power 1 times half is just half, and we reduce the power by 1 to get x to the 0, which is 1. So it's half. Du by dx is half. So that means when you make dx the subject, dx will be, well, it's going to be du over half. Du over half is the same as 2 du, alright? It's going to be 2 du when you transpose to make dx the subject, alright? Multiply both sides by dx, because you're treating du by dx as a fraction. So dx would come here and then divide by half. It's du over half is the same as du times 2. So it's 2 du. So dx is 2 du. So the integral of e to the u du, but du is times 2. Let's put the 2 here. What's the integral of e to the u du? Is e to the u. So it's just like how the integral of e to the x dx is e to the x. The integral of e to the u du is e to the u. So it's 2e to the u. Right? But what was u again? U was half. Oh, yeah. It was half x, right? U was half x. So it's 2 e to the half x. That's what we get when you integrate that. So the integral of e to the half x is going to be 2 e to the half x. Now, if you remember your integration by substitution, you remember that when you integrate e to the ax dx is going to be e to the ax over a plus c. Alright? This is like e to the half x over half, but over half means times 2. Alright? So, here now, the integral of d by dx of, we don't run out of scrolling space, we worked it out. So, it's 2 e to the half x. Let's just erase this. You could write down the notes when you finish. But you'd have to pause and write these things down. So the integral of the derivative of y e to the half x squared dx is equal to e to the half x. But the integral of e to the half x dx. But the integral of e to the half x dx is going to be 2e to the half x plus c. So this works out to be 2e to the half x plus c. Now what does this work out to be? Well, it's as if the integral and the derivative cancel each other, leaving the function undisturbed. So y e to the half x squared is equal to 2e to the half x plus c. We want y equal, so let's divide both sides by half x squared. So what we have here is y is equal to 2e to the half x over e to the half x squared plus c over e to the half x squared. Now this is going to be y equals 2 e to the half x minus half x squared plus c e to the negative half x squared. Alright? Alright, so let's copy it and bring it somewhere else and simplify it because we run out of scrolling space there. So let's copy and combine these. So what we get is y equals 2e to the half x minus half x squared plus c e to the negative half x squared. Alright, so that's what we have there. So let's bring it somewhere here and finish. So y equals 2e to the, well, we could factor out the half and get x minus x. Oh, we could factor out half x. Half x and get 1 minus x, 1 minus x plus c e to the negative half x squared. Alright, good. So that's the general solution. Now suppose we're given initial condition. Let y of 0 be equal to 1. Right. Same as saying x is 0, y equal 1. So that would be 1 is equal to 2 e to the half x. This would be 0, e to the 0, plus c e to the, well, negative half times 0 squared is 0. So 1 is equal to, e to the 0 is 1. So 1 is equal to 2 plus c. So c would be 1 minus 2, which is negative 1. C would be negative 1. So that particular solution there would be y is equal to 2e to the half x, 1 minus x, minus e to the negative half x squared. Alright? Or instead of writing it like this, we could put 1 over e to the positive half x squared. Same thing if you remember your indices. Why I write the 2 like this? Let me rewrite the 2 here. Okay. So that would be c is negative 1. So I have a negative here. 1 over e to the half x squared.